We are solving NEET 2018 question, a free body basing on laws of motion and free body diagram, connected bodies. The problem is like this. A block of mass m, this is this one, placed on a smooth inclined plane of wedge, this one, ABC, has shown with an angle of inclination, theta. The wedge is given an acceleration towards the right, this way. Then the relation between A and theta so that block remains stationary, right? Let's understand basics and how do we solve this problem so that we can get to an answer. Let me redraw the diagram for you. This is the wedge I am drawing with an angle theta. There is a block of mass m placed on the top of that small m. Let's talk about this block first. Its weight obviously always acts in vertically downward direction, which can be resolved into components as this angle is theta, this angle is also theta. So for this mg, this becomes, because of adjacent to theta, adjacent component, that is mg cos theta. And the other component is automatically like this. Sorry. Other component is vertical component mg sin theta. That's the first part of the problem. Now let's talk about the acceleration given to it towards the right. There's an acceleration given to that system, A towards the right. Here, acceleration is given. This acceleration given to the wedge makes the frame of reference of this block non-inertial because the block is, as the wedge being a frame of reference, is having some acceleration that becomes a non-inertial frame on which we are trying to study the body. So, to compensate the non-inertial frame where we cannot apply Newton laws of motion, we shall imagine an acceleration on the body of equal magnitude but opposite direction. So, this is what we are imagining: a pseudo acceleration so that we can come out of the influence of the non-inertial frame of that. Being this angle is theta, this angle also becomes theta. So there will be a pseudo force, MA pseudo, which can be again resolved into components as this becomes its adjacent component, MA cos theta. This becomes its vertical component, MA sin theta. For the block to remain stationary, the force acting in downward direction is mg sin theta. Force acting upward direction is horizontal component of that pseudo force. MA cos theta, m and m can cancel. Then what we can say is A equal to G sin theta by cos theta, that equal to G tan theta. So it shall have an acceleration of A equal to G tan theta so that the block remains stationary. We have taken only the forces along the inclined plane. We can also say the other part, which is of course not necessary in the problem. We can say normal reaction as mg cos theta downward minus ma sin theta, who is acting upward. That's of course not required in this problem because it's a frictionless smooth surface. So I need not worry about that aspect, but still I got the answer that what is required. So the most important thing in this journey is you need to know that as the frame of reference, the wedge, this entire wedge, is having some acceleration. It becomes a non-inertial frame. We cannot study the motion of the bodies in a non-inertial frame, this block. So on that block, we shall imagine a pseudo force that's of equal magnitude, but in the opposite direction, so that I have nullified the influence of that pseudo force. That's how we have to solve the problem. That's it. Thank you for watching.